All right, so thanks folks for coming in on a, Tuesday afternoon. San Diego's a great place to do Cisco Live, but it's also a horrible place to get motivated to come inside and sit still for 2 hours. Myself included, so if you guys, if we decide we want to go outside and have the session outside, I mean, I'll take you up on that. We can go outside and just, sit out there by the harbor. So my name is Matt Bolick. My email address is just bolick@cisco.com, so just my last name. So by coming to a session, you automatically get the right to send me an email at any point in time. So send me an email, ask me a question, sign me up for spam. That's fine. I kind of expect that. So I'm currently a technical marketing engineer. I kind of do a couple of different roles in between senior TME and TME manager. I've been a TME at Cisco for 23 years. I actually started way back in 1996 as an intern from NC State as a technical marketing engineer. And in 1996, it was such a small company that you could be a college student and be the TME for ATM switching. Nobody, kind of called BS on that, so it was a lot of fun. So basically what that really means is that I'm still kind of looking for my first after-college job. So if any of you guys have any openings, there was one guy in a session I did a couple years ago from the University of Hawaii. And in the session, I was just like, so if you've got any openings in Hawaii, and he came up to me after the session. So if anybody here from Hawaii? Crap. Okay, well, I'm still trying. So this session is one that we've done that I've done at Cisco Live for, about 5 or 6 years, maybe even more than that. I've been on the ISRs. I've been on a lot of different products. Most of them are end of sale. Most of them are no longer with us. On the ISRs, I've been on branch routing since 2007, so about 12 years. I've done this session for probably about a decade or so, and it's different every time. What I like to do is a combination, roughly about 50-50 of, hey, this is how we think about branch routing at Cisco. These are the processes, these are the thought processes that we go through when we're designing a new router. This is what we look at when, we're kind of evaluating, what are we supposed to, what do we need to have out there for the next 5-6 years, that kind of thing. And then also go through the architecture for folks that are new to the ISRs, that are new to it. We'll go through, packet flows. We'll go through block diagrams. We'll go through portfolio overviews so that you get a feel for, this is what it means to be a branch router from Cisco at least. And this is where things, kind of fit and play, into the portfolio. So ideally, this session should have something for, folks that are completely new to Cisco routers, that are completely new to branch routers and ISRs. And it should also have some stuff for folks that come back every year and just want to say, hey, what's new since last year? What have you got? What's new? It's a very interactive session, so please ask questions. I have a little bit of a reputation at Cisco for telling you way more than I'm supposed to. So you guys are now all sworn to NDA agreements. Everybody agree? Anybody? Okay, cool. All right, Scout's honor. Okay. So seriously, ask me questions. I mean, I've got stories that go back 20 years. If they get kind of old and dry and boring, don't tell me to my face, but it'll kind of hurt my feelings. But no, seriously, ask questions. This is generally a very interactive session. I want to make sure that I'm, addressing exactly what you're looking for out of the sessions. You don't want to sit here for 2 hours and just have this question burning that, you just let me drone on for 2 hours, because then we'll all go to sleep, and it's really embarrassing when I go to sleep up here at the front. Cool. So what we'll talk about is, how is an ISR born? We'll start out with that. We'll hit the 7th grade biology lesson right off the get-go. So first a mommy router and a daddy router in love, and then they go and they meet a stork. Now, so we'll talk about how the design kind of comes to be. We'll talk about the history and something that we take really seriously on branch routing, and that's basically really being reactive and responsive to what customers are telling us. Product managers do fail on that sometimes, like the discussion we were having earlier. But we'll talk through that and how that works. Then I'll just go through the portfolio, and we'll it'll be an opportunity for you to ask questions as we go. We'll dig into the architecture. I can talk about the background of the architecture, where it came from, the relationship to the ASR 1000, the relationship to other Cisco products, if you're interested in that. We can go in a lot of different directions depending on what you guys are interested in. But just as a core of it, I'll talk through the ISR portfolio. The 4000, the 1000. How many of you guys have heard of the ISR 900 series? All right, so go check out Cisco blogs. There's a phenomenal blog by this guy. I don't know what his name was, Matt something or other at Cisco. introducing the ISR 900 series. It's a really cool box. How many of you guys have 800 series in your networks? Okay, so you'll really want to look at the 900 series because we did some really interesting things with that. Enterprise NFV, how many of you folks are interested in NFV? That was kind of the buzzword about 2 years ago for everyone in the industry. I'll talk about our NFV portfolio and how that relates to the ISR portfolio. I'll talk about application hosting. I'll talk about the UCSEs right after that, and application hosting on the routers, just to kind of give you a more rounded kind of story for what we mean by integrated services, because there's so much more than just routing. Routing is almost, it's table stakes. That's really not what we do anymore. I mean, of course we do routing, but we do so much more above and beyond that. And that really is what we talk about in that first section, really. And then I've got a section on modules that, it's there primarily as a reference for you guys. We can talk through individual modules if you're interested in it. I'm not going to kill you with, with 50 different modules and different flavors and things, unless you're, really sadistic and you want to go through that. We can certainly do that. There are a lot of slides in this presentation that I've marked with, for your reference at the top. There's way more than we'll go into, in terms of in-depth detail, in this 2 hours. Download the slides. I did make some slight tweaks to the order. I'm a habitual slide mangler, so I did make some slight tweaks right before the session. But if you go download them from the Cisco Live app, you'll see pretty much the gist of everything that's there. Okay. Any questions before we get started? All right. Cool. How long will the what be out there? The presentation will be out there on Cisco Live, I think, forever. I don't know when it actually gets taken down, but it's there for a long time. Yeah. You can actually do Google searches and find it forever, I know that. So anyway. So WebEx Teams, like I mentioned earlier, there is, if you're using the WebEx Teams app, that's, a real convenient way to ask questions. You can also send me an email, just bolick@cisco.com. Either one works perfectly fine. If you ask it in the WebEx team, other people can see your question and maybe learn from what you've asked as well. So definitely take a look at that. You should all be a member of that WebEx Teams group now. All right. So how a branch router is born. So let's rewind the Wayback Machine, all the way back to our earliest branch router, our earliest router that was designed specifically to fit into a branch office. That would be the 2500 way back in 1993. Really interesting thing is we have a lot of engineers that are working on the ISRs today that worked on that original 2500 series. There's not a whole lot of turnover in the ISR engineering team. We're primarily based in San Jose and RTP, Research Triangle Park in North Carolina. We have a amazingly low turnover rate for engineers in RTP. It's a great place to work, and we honestly don't have a lot of other places to go. So that's why we don't move very often. I'm an RTP myself. So 2500, the first router we ever built, designed to go into a branch office, small 1 RU footprint. We would call it today a fixed configuration, in that it's not modular. Basically, you buy all of the interfaces that you want in that box, right from the get-go. We call an 800 series, if you're familiar with that. That would also be a fixed configuration router. So really popular router. We still run into those. I still have 2511s, in my lab today. It would make great terminal servers. So, really rock solid box. We evolved that. The next box that came out was a 2600, 3600, also designed in RTP. That was our first modular branch office box. It was the first box that we actually started integrating services into the product. Security was the first thing that we integrated into it. We had firewalls for the first time. We had some really basic VPN technologies available there. So it was the first time when we started to tip our toe into more than just a router in the network. The next box was the first platform, the first family that we actually called the integrated services routers, the ISRs. In hindsight, we refer to them as the ISR G1s for generation 1. That'd be the 18s, the 28s, and the 3800 series. Now, the big thing that we did with those is we added voice. So this was around the 2000s, 2004, when IP telephony was really starting to take off. And so we were, trying to read the tea leaves and figure out, what's coming out next between, the next 4 to 6 years. What do we need to have available in our branch offices? What are our, branch customers needing in the same place as this router? And we said, okay, voice is the current technology. It's the current trend that's really driving our design. And that's what we incorporated in the ISR G1s. Same thing happened with the ISR G2. So A few years later, it's time to start working on the ISR G2s, the 1900s, the 2900s, and 3900 series. And the big thing that was, the big topic that was front of mind then was really virtualization, integrated compute, basically doing some sort of a server, some sort of application hosting on the router itself. So that's where the UCSEs came from. That's where we first introduced those. So if that would be the first place that you could actually have a server inside of your router. So you can now do security, you can do voice, you can do virtualization, all on the same box. Okay. So that served us really well all up until 2009. What happened after that, as we moved to 2013 and 2014, is like I was saying up here, very briefly, our hands were tied a little bit by what CPU vendors were doing. If you take a look at well, it's not even there, but the 3900X, the 3945X, the 3925X, or 3925Es, sorry, the E series, those were the biggest routers we could possibly build with an Intel x86 CPU, simply because all before this generation, all of these guys were classic iOS based, or what we call classic iOS. That was the operating system that we had all the way back to the 90s. Great operating system. It was phenomenal for getting predictable performance, getting predictable order of operations out of packets. Downside was that it only used a single CPU core, only a single thread. So we needed to have big, large, monolithic CPUs to get any kind of performance out of it. So that 3900E series had the very biggest, most powerful industrial long-term support x86 CPU that Intel made in it at the time, and that was the top of the line. We couldn't build anything faster with that architecture. Around about the same time, we had the ASR 1000 series, our aggregation product, and that they had been working on iOS XE, a new operating system that used that same classic iOS as kind of the core control plane, and then used a multi-core data plane. We'll get a little bit more into that architecture a little bit later, but suffice it to say, what we essentially did was we took that architecture, brought it down into off-the-shelf CPUs, and that's where the ISR 4000s come from. Okay, so that's why you see an architectural difference that we were talking about, and that's why you see a little bit difference in terms of the features, the performance. That's why we have new modules for these guys. It's still the ISR. We still fit into the same use cases, but it's a little bit different in terms of an architecture. Same thing's happening on the Catalyst side, on the Ethernet switch side of things, but that's basically where we came into this. So the real thing that really drove this change was the need to move to a multi-core architecture. To get more predictable performance, to get hosted applications. So this is the first time we actually did virtualization on the platform itself. So now you no longer have to have a dedicated module to host applications. You can now host applications directly on the hardware itself. So some pretty cool changes there. Okay. What's coming out next? Well, ISR 1000 series, that's the next latest thing that we just introduced about a year ago. ISR 1000 series takes this architecture, brings it down even further, down to about the 1900 series where we would have been previously. The biggest change there, to be honest with you, is not something you would ever see from a customer standpoint, is we moved from Intel x86 CPUs here to ARM CPUs with the ISR 1000s. And if you know anything about CPU architectures, that was a big stinking deal. Because we went from a little Indian architecture with Intel CPUs to a big Indian architecture with ARM. That was a massive amount of work. But the result was this ISR 1000 family. It let us get that iOS XE architecture down to a small enough footprint, small enough price point that we never really could have before. Okay, so that's kind of the evolution there. And then the follow-on to that was the ISR 900 series that we did just last year, and I'll talk a little bit more about that as we go. Now, there's a whole lot of stuff in here I didn't talk about, a whole lot of other routers that kind of fit in between things. But you can see we followed a pretty even cadence here, 2004, 2009, about 5 years between here. And so we're on a pretty repeatable, pretty regular curve. The other thing that's kind of unique about the ISRs, certainly within Cisco, is that we tend to retain support for a previous generation until at least halfway through the product lifecycle of the next generation. So we're really unique inside of Cisco. As a matter of fact, those ISR G2s that we were just talking about, we only just recently dropped. We only just recently end-of-saled all of the ISR G2s. So we've been working on that for a while. So we tend to have a lot of overlap in our portfolio. Okay. How many of you guys still have ISR G2s in your network? I think I asked that. Anyone still have ISR G1s in your network? All right.
Maybe.
the bold. Anyone have 2600, 3600s in your network still? All right, anyone still have 2500s? Don't admit that, because I'm sure there's more than a couple P-certs out there for 2500s. But yeah, no, it's a phenomenally rich product line. And the thing that always blew me away about it is the level of detail that goes into the hardware design of these boxes. If you guys want to hear nauseating little stories about the power bus design on a 4451, ask those questions, because there's some beautiful pieces of engineering that you'll never see on a lot of these routers. So what's the thing that's moving the needle today? What's the thing that we see as kind of being the next step that's driving certainly the 4400s and the 1000s, in terms of the feedback, the place that we see the network going? It's SD-WAN. And it's SD-WAN in general. It's really the more of the concepts of the changes in the WAN environments. The proliferation of devices, the Internet of Things, the bring your own devices in an enterprise context. That security footprint that is drastically changing around the world. It's the move to the cloud with some cloud offload capabilities, the ability to do some compute there at the edge, along with some coordinated compute in a cloud environment. And it's those mobile users, which is essentially an explosion of those devices, of those things at the edge. And that's all leading to that, that change in the WAN environment. So, basically people are looking at using the WAN in different ways than we ever really have before. And a lot of this is happening organically. It's not like there's, we can point to a single technology that really changed the whole game for everything. I mean, SD-WAN, as great as it is and as much as we love to talk about it, it's not a single technology. There's a lot of things that are happening at the same time, whether it's, reliability of business internet circuits, it's the availability of LTE, it's the proliferation of cloud service providers, it's, cloud services in general. Those are all things that are, changing and just kind of rewriting what we have to do as IT organizations. Simple things like the changes in IT budget staffing, and the fact that, if I had gone to an IT department, 15 years ago and said, here's a new ISR, there would have been a team of folks there that, all they did was ISRs all day long. Well, you go to most organizations today and I say, here's a new ISR, and they say, great. Here's 20 other things that I have to manage on a daily basis. So it's making the entire network much more intuitive, much more usable, with different characteristics that you no longer, can be relied on to have an expert on your product, on your technology, on just your branch environment in a lot of cases. So those are kind of minor changes that we're kind of attempting to address with what we're doing with SD-WAN. Reducing the time to deploy, things like zero-touch deployment, things like the ability to pre-provision and configure things ahead of time to take advantage of redundant links, to reduce the expense on things like MPLS circuits, where you can move to business-grade public internet circuits. Those types of things are things that customers are asking us about constantly. We just happen to package all of that up into a nice little bundle and call it SD-WAN. So those are things that are definitely happening all around. So how can I roll out my network without really waiting on a service provider? How can I make changes to my network without a lot of staging and pre-positioning and configuration before rolling it out? Those types of things are questions that we get asked constantly. How can I integrate some of my workloads with the cloud? How can I do some coordination between services in the cloud versus doing some sort of processing local intelligence locally? How can I add application awareness, especially for cloud applications, to my network, so that my network is now, my branch router is now aware of traffic that's going to Office 365. It's not just doing some basic quality of service on application matching. It's actually looking deep inside of the traffic flow there. How can I simplify the architecture? Because I can't manage just a branch router anymore. I have to do a dozen different things. And so, I need this to be, customizable, but I need it to be within some guardrails of, what are some pre-planned designs? How is this easy for my network operators to actually manage and troubleshoot and deal with? And then, of course, security. Security is kind of the thing that is, the bugaboo for everybody. So we have to have complete end-to-end security over the top of whatever transport has to be underneath. So that's always going to be, front and center. So these are all requirements that, customers are coming to us and asking us around about the time we were designing the 4400s, around the time we were designing the ISR 1000s. And so we incorporated all of that into those product designs. So the evolution of the WAN, if we take a slightly sidestep and we look at what we're being asked to do in this SD-WAN kind of world. First off, we're going to have a transport independent fabric. If you've been to any SD-WAN sessions here this week, these are all, or really honestly from any vendor, not just necessarily from Cisco, these are all going to be kind of common terms. These are common overlay kind of ways of thinking about things. You're going to have an overlay topology. You're going to have a fabric that is going to be agnostic of everything else that's underneath. So you can switch out service provider A for service provider B in different parts of the country or different parts of the world, or just based on who happens to have the best pricing, this day of the week. Those are all going to be there. You're going to have, cloud-delivered WAN intelligence. So basically, your monitoring, your management, all of your tools need to be ubiquitous and in the cloud. So we're seeing a big push from customers to, move a lot of that management, move a lot of that intelligence off to the cloud, so you don't have to maintain that infrastructure. That's a big thing that we're seeing. It doesn't necessarily hit all customers. There's still a lot of customers that like to have things on premises, but we're seeing a big push to move things, up to a cloud, so you just don't have to worry about it. What happens with your management tools there. Security, of course, end to end. You've got to have a secure infrastructure, and not just secure transport, but you need to have built-in firewalls. You need to have deep packet inspections. You need to have intrusion prevention, all kind of as a native feature of the network itself. It needs to be both application aware, and it also needs to be what we call application quality of experience. So it needs to basically not just be application of aware, but it also needs to make sure that it is maintaining the appropriate levels of quality for that application, whether it's a latency sensitive voice or video application, or maybe it's a bandwidth sensitive, database application, that type of thing. Those are kind of key to the network itself. Endpoint flexibility, and this is kind of a side effect of our architecture, and it's something that does get asked about quite a bit from customers, and it's we need to have options for the physical world, for the virtual world, for cloud hosted networks. We need to have options for at lots of different price points and sizes and capabilities. We need to have hardened devices playing really nicely with carpeted spaces and quiet business areas. So there's lots of different form factors that we have to address with that. And then finally, it's building the cherry on top, all of the sweet things that come in addition once you've got all of these common requirements really delivered. So it's the ability to deliver cloud-based services. It's the ability to do analytics on top of that to see what the performance is for all of your applications, where you have packet loss, who's using the network, what types of devices are using the network, and really shorten your mean time to recovery when you have a problem, when you have a failure, something like that. So these are all things that we're getting asked about, when we're looking at that, what's the next thing? What's the next thing for an ISR? What's the next box that we build, in a branch environment? So how many of you guys remember when we bought Viptela? Is that still key on you guys? So this was actually something that, I'll talk a little bit more in terms of, how we physically did that. So we had, if you remember a few years ago, we had the Cisco iWAN solution, and the iWAN solution was addressing, a lot of these needs, a lot of these requirements, that we were getting from customers. So basically, we were getting these requirements, we were getting these concerns from customers, and we built the ISR 4000s, we built the 1000s. We had our iWAN solution, and iWAN solution was hitting all of these requirements. The only thing that was really missing was a nice, clean, simple, approachable, kind of management style, and that's really what we did with Viptela. So we acquired Viptela, we brought them in, they basically became our SD-WAN overlay for the network. All of the underlying components of that ISR 4000, all of the features, all of the capabilities, they're still there, and I'll talk about that when we get into a little bit of the architecture. So when we look at SD-WAN on a Cisco ISR or on an ASR or on even a CSR, a virtual router, it's all the same data plane, it's the same software under the hood, but the overlay, the actual high-level interface, that's where things really change. So when we look at this model that we brought in with that Viptela acquisition, you get a separate management plane. So it's a common management plane, it's a single pane of glass, it's a nice, clean, simple GUI that is approachable for IT staff that don't spend all day, every day, looking at an ISR. That's first and foremost, to be honest with you, the big thing we were lacking with IWAN is that it was not really an approachable solution. It was something that was ridiculously powerful. We had all of the requirements, all of the capabilities, but it took a lot of time and understanding to really deploy it properly. So we have that. We have the control plane that basically ties all of the nodes together, that builds that overlay mesh network. It's all based on BGP with some additional tweaks, some additional attributes to that, but it is a true overlay kind of routing protocol. The data plane underneath, how you actually move packets, the actual features that you do to move bits around the network, that's all classic ISRs. So that data plane is all still there. That's all of the stuff that you're familiar with today. So if you have an ISR 4000, an ISR 2900 today, the data plane component is still pretty much the same. When you move to an SD-WAN world, you're just adding on this management plane and that control plane there. And then, of course, once you do all of that, you've got the ability to do analytics, because we're looking deep into the applications. We're making forwarding decisions on applications. We're maintaining that application quality, and we can monitor that. We can measure all of that in near real time, so you can really learn what's happening in your network. Okay, so this is kind of the thought process that we're going through, when we I didn't realize that was an animation slide, when we design the next generation of routers. So any questions on that? What our thought process was, how we looked at things, any big requirements that we're missing? To be honest with you, these Cisco Live sessions are the best place for me to find out, what are we missing for the next generation? Yeah.
So, everybody's trying to go to Viptela and or go with that design. And so I'm hearing the code is not ready until November. Is that true or not true? Or?
So you're asking about Viptela code on the ISRs?
Yep.
So Viptela code has been shipping on the ISRs for about a year now, but we're constantly adding features and functionality to it. So depending on exactly what you're looking for, there is a release coming in November, and that I've actually got some roadmaps on SD-WAN integrations, so hold that until that section. Code's shipping today, it's in deployment to a lot of customers. It's just depending on what functionality and what platform you're looking for, may not be until that November release. Yeah. Okay. Any other comments on things that we're missing? Things that we just kind of missed the boat on? You guys are being quiet. All right. So ISR 4000s, how many folks know everything about the ISR 4000? How many folks know anything about the ISR 4000? Anything. All right, great. How many folks know something more than the fact that there's an ISR in the name? All right, excellent. All right, cool. So the current enterprise routing portfolio today, I'll just give you a kind of a roadmap here to kind of tell you where everything kind of fits together. Now, this is the enterprise routing roadmap, not to be confused with our extended routing roadmap, our service provider, routing portfolio, or even our IoT portfolio. So, if you're familiar with our IoT products, they are all very closely related to these routers. Basically, the IRs, the IEs, the IWs are all basically hardened versions of our enterprise routing, switching, and wireless products. So I can certainly answer questions about those if you're interested. In a nutshell, it's just basically the IoT devices are broader temperature ranges and basically these boxes in places you don't want to go to. That's kind of the IoT boxes. So in the branch specifically, we've got the ISR 900, 1000, and 4000. We'll talk a little bit about what maps to previous generations and that kind of thing. So the 900 is definitely the smaller routers. That's going to be your smaller devices, your smaller branches. Typically 4 to 10 users would probably be about the sweet spot for a 900 series. They're small, they're fanless. One of the biggest complaints, to be honest with you, we've gotten on the ISRs over the years is fan noise. You would be amazed the level of work that we go through to make the ISRs with fans as quiet as possible. We even on the ISR 4000s, we actually have an altitude sensor. There's a barometer on it. And we actually spin the fan slower if you're at a lower altitude because air is denser, it cools more efficiently. So it's ridiculous the level of detail we go to make those devices quieter. A lot of times it's just easier to take the fans off and do some really complicated heat piping and movement of air to get it cool. So 900 series completely silent because there is no moving fan. Fans also coincidentally happen to be the, outside of the power feed from the service provider, from the power company. The fans are the most common failures in any device, whether it's a switch, a router, a server, whatever. It's because they're moving. So that's that increases reliability when we can remove those. ISR 1000s, that's going to be our first modular box. In that we have actual interface modules that you can swap out to change from an LTE to a DSL to whatever interface that you need. It's going to be a little bit limited, but you do have that option. When you move up to the ISR 4000, that's when all bets are off. It's a completely modular system. You have modules for everything under the sun. Just about any possibility for an interface type, you're going to have something in there for the ISR 4000. Now, also in the branch, we do still have the Viptela platforms, the V-Edge, the 100, the 1000, the 2000, and then up here the 5000. So those are not going away. We have a lot of legacy Viptela customers that that still like those V-Edge boxes. They basically don't need to do anything other than Ethernet and occasionally LTE. And those are good boxes for those use cases. They're only going to do SD-WAN. If you're looking at something like a 1000, a 4000, an ASR 1000 as a head-end aggregation box, those can do SD-WAN. They can do traditional, classic IOSXC. So depending on whether you're doing, management styles that you've done in the past, traditional network management, SNMP network management, or CLI, you can do that. Or you can move into the SD-WAN realm and actually use that Viptela overlay. On that aggregation side of things, we do have the ASR 1000. How many of you guys are familiar with the 1000, ASR 1K? ASR 1K is essentially the same architecture as an ISR 4000. CLI, the interfaces, the configurations are almost exactly the same. And that's simply because we stole that architecture from the ASR 1000. So there's a lot of commonality there. Same thing on the virtual platforms here, the CSR, the Cloud Services Router. That's a virtual IOSXC router, so it looks very, very similar to an ISR 4000 or an ASR 1000 or an ISR 1000. So it's a common code base. It's the same code. It's literally the same code between all of those platforms. Okay. The ENCS platform, we'll talk about that a little bit later when we get into NFV. That's our fully virtualized platform. Okay. Any questions on the portfolio? Anything that sticks out about you guys that that you might want to know a little bit more about? Yeah.
Is there anything or any ideas to replace the ESR series?
So the ESR series you're talking about on the hardened industrial router?
Yeah, just the little versus a motherboard.
Yeah. So the ESR series is he's asking if there's any plans to replace the ESR series. That's in the IoT product set. As far as I'm aware of, there are no immediate plans to replace the ESR. However, we did just release the IR 1101, which is sort of an IoT version of this box. So I don't know if there are plans to replace that ESR anytime soon. If you go to the World of Solutions and look in the IoT area, they've got an ESR there. You can ask about that. I wouldn't be surprised if there's a follow-on to that hardened version of that in the ESR form factor. Yeah.
Why did you call the 1000 LTE router when there's no LTE? What do you mean?
The 1000 LTE router. I don't know what you mean there.
One of the ISR routers is is it a 1104
Yeah.
LTE that came without LTE module? You have to buy a module.
Oh, so you're asking about something that's not on this slide.
Isn't it
I'll talk about the 1000s in a few minutes, and we can talk about that specifically. Okay. I thought he was reading a 1000 LTE on the slide, and I was getting lost there. Yeah.
Something comparable to the 891 with 24 foot disc, because we find with some of our renters, we have, that are
Yeah.
renters, but just the number of AP, with large footprint sites,
Did-
industrial and.
Have you deployed a lot of those 891 24Xs?
We've had them but now, previously,
Yeah.
now that we're, using the 1000, end up using the sites 1000, we're having to add another switch.
Yeah.
We need around a 10 to 12, the 8 does not put anything.
I got you. So she's asking about the 891 24X. The 891.24x was a really cool router. It was an 891 that had a 24-port Ethernet switch on it. It's less functional than a Catalyst switch. This is a case of me telling you way more than I'm supposed to. The problem with the 891.24x is that we were politely forced to price it on a per-port basis about the same as a 24-port Catalyst switch, but it's significantly less functional than that, so we don't have a lot of people that are using them. Just simply because that. Short answer is I'm not aware of any plans to build a follow-on to that. I love that box. That was one of our first.
For the size of some of our sites,
Yeah.
that's perfect. You know, buying a 4,000 for those sites is
It's overkill.
overkill.
Yeah, yeah.
Overkill, and the 1,000, we end up having to buy a second switch to cover usually a handful of ports that we need.
Yeah. I mean, sorry, I don't really have a good answer for you other than that the PMs have essentially decided that, the correct answer in a situation like that is a 1,000 plus, like a compact switch probably or something like that.
The 2960CX.
Yeah. And to be honest with you, you're probably around about the same. You're probably less expensive than an 891.24 in some cases.
It's about the same.
Yeah, it's just not as convenient.
Our sites, that's what we've done.
Yeah.
The older sites still have the 891.
Not quite as convenient though, you're right, yeah. Okay, any other questions before I get moving? All right, so the trying to remember what the next slide is. All right, there we go. So the ISR 4000, this is the big wow slide when we launch a box. So the ISR 4000, what did it really bring in? So it brought in a multi-core architecture. That's really the big kind of top of line thing is that for the first time we had a real multi-core split control plane data plane architecture in a branch router, and that let us do a whole lot of things. We actually called it. Is it actually up here? We actually had what we called ASIC-like performance because it basically took the ASIC architecture of an ASR 1000 and made it affordable. So we took all of the code that ran on the QFP, the quantum flow processor ASIC in an ASR 1000, and we run it in an off-the-shelf CPU. So you get the same sort of behavior that you get in an ASR 1000, just at a lower price point and lower overall performance. That really means that this box was designed for layer 4 through 7 services. It was designed to be much, much more than just a layer 3 router. It was designed for SD-WAN, IWAN, SD-WAN. That was kind of the top of line things that we were thinking about with this box. It was designed with virtualization in mind. iOS XE is a Linux-based architecture. It's a Linux operating system. So it was really easy, or straightforward, I should say, for us to do application hosting, to do virtualization, Linux virtualization on the box itself. So those are kind of the top things that we had in there. Pay as you grow, that's something that customers have asked us for a lot in over the years. Just typically what customers will tell us is that the truck roll is the single most expensive thing in running their branch environment. Actually physically sending someone out there, a trained person out there on site, is the most expensive thing. So if you're moving to Metro Ethernet handoffs from a service provider, it's really easy to call them up and say, hey, change my train rate from 100 megs to 300 megs, or something like that. What we did with the ISR 4000, since we have a multi-core data plane architecture, it's really easy for us to license those CPU cores to basically say, you've got a 100 meg box, we can just turn on some of those additional cores, you've got a 300 meg box. So that's really what we meant when we came out with that capability. Okay. So the 4000 series, it's grown a little bit, since 2013 when we launched the first 4451. We now go all the way down to the 4221, which we generally target at 35 to 75 kind of megabits per second as a WAN speed, all the way up to the 4461 now. 4461 will do 3 gigs and above. We kind of say that's the first ISR we've ever done with a 10 gig interface on it, simply because we're pushing speeds faster than 1 gig today. So we've got a pretty wide range of performance. This range is kind of what I was talking about there, that pay-as-you-grow performance. So we have a base level of performance. You can buy a license for it, and it'll turn on additional CPU cores there, and it basically increases the performance to something more. Rather than licensing every individual core separately and making it a real nightmare, we just did a bulk license. So there's a base license and a performance license on top of that. Okay. Is there any plans to go beyond 3 gigs? It's called an AS. We would generally transition over to the ASR. The ASR 1000s would be above that. What's that? There's no what support? There is container support in the ASR. It's just not as flexible. And I've got a section on containers there. It's probably not a bad thing that you don't have the same level of container support on an ASR that you do here, simply because containers really make the most sense kind of down here in this part of the portfolio. Yeah. Okay. Yeah.
Question on the 4431, when you say 100 megabits per second, is that, we don't ask that question, but does that mean that you get 100 megabits?
That's data plane performance. On this slide, that means data plane performance. Now, when we get into the SD-WAN world, just to make things confusing, it's different. So when we talk about ISR performance, non-SD-WAN performance, that's just the performance of the data plane. So the data plane doesn't care whether a packet comes from the WAN or goes to the WAN or comes from the LAN, or doesn't care.
But throughput on the port, say, as an example, you can get 500 megs in, 500 megs out, right?
That would be 1 gig, because you're forwarding 1 gig of traffic.
There's a big debate on what that actual number means.
Yeah.
Does that mean it's 250 in and 250 out?
It means that the data plane, if you have a 1 gig license, for example, it means that that data plane can forward 1 gigabits per second of packets. The actual mixture, that could be 500 megs bidirectional, because that data plane has to forward all of that traffic. That could be 250, 750. It could be all 1 gig.
It can only handle what you just said.
Yeah, yeah. And it's 1 gig of, that's what the data plane can process. Yeah. Yeah, we tried to make it very ASIC-like, and that's, if you look at it from an ASIC perspective, the ASIC has 1 gig of capacity. So that's kind of where that came from. That's going to generate confusion when I get to the SD-WAN, so just kind of hold that. Yeah.
So that's just layer 2 performance at that point, right? When you start adding voice and firewall and everything.
That's layer 3 performance. So I'll talk a little bit about performance as we go. We're jumping ahead a lot here, so.
How do you count for multicasting? If I run one multicasting will be in and two goes out, how do you calculate?
So multicasting is every time you forward a packet, it counts. So if you have 2 replications, then you count every replication. To be totally accurate, every time you forward a packet, it counts against your box capacity. So receiving a packet technically does not count, because you can drop a packet really efficiently. But actually forwarding a packet, and in the case of multicast, every time you replicate a packet, it would count.
Right, for example, multicasting, if you do the replication twice, in the ISR for one, you're going to do 500 back if you do 2 replications, right?
That's true, yeah, yeah. So on a 4431 with a 1 gig license, if you have to replicate every packet one time, you can only forward 500 megabits per second, because that would be your 1 gig. Yeah, that 500 meg would become 1 gig, okay? Okay, so the 400 family I/O design, this looks very similar to previous generation ISR, so I'm not gonna spend a whole lot of time with that. The one thing I will point out is that we always try to give you some interfaces just as the base platform. In an ISR, there is no distinction between a module, between interfaces. We have all full capabilities on all interfaces. There's no LAN interface or WAN interface. Sometimes people will refer to these as your WAN interfaces. That's fine. You can call them a WAN interface, but there's nothing special that makes them a WAN interface. They can be a LAN interface. Doesn't matter. These are all layer 3 capable. They all tie directly into the data plane of the system. Now, the one exception to that is this little guy off to the side, the management interface. And this is a little bit of a holdover from our architecture in that we now have a separate control plane and a separate data plane. Well, that control plane CPU is an x86, it's an Intel CPU, it includes an Ethernet interface as part of it, but it's the control plane, it's not the data plane. So we can tie that Ethernet interface right here to the front of the router. In a branch environment, you're probably never going to use it. You're probably never going to have an out-of-band management network in a remote site branch. If you're in a data center, if you're in a place that actually does have an out-of-band management network, that's a great place to manage the box. You cannot pass actual data plane traffic through it. It actually resides on a separate internal management VRF. So you can't accidentally route to this interface. Okay? Other than that, fairly straightforward modular architecture. We have 2 major sizes of interfaces. We call them enhanced service modules, or SM-Xs. The ISRG2 modules were just service modules, so we added an X to that. And then we have network interface modules, or NIMs. How many of you guys are old enough to remember the old Cisco 4000 series, the 4700, the 4500 series? Anybody remember what the name for those modules were? the old knuckle busters that would make your knuckles bleed. They were called NIMS. I'm really proud that I got this name. And I tried really hard to call this the 4700, but branding wouldn't let me do that. Anyway, so I've really tried to, but they wouldn't. So the major families that we have in the ISR 4000s are the 4300s and the 4400 series. There is a little bit of difference between the two of them. The biggest difference from a practical standpoint is the 4400s have dual power supplies. 4300s are single power supplies only. It's another one of those product management decisions. I don't apologize for that, but 4300s are essentially single power supplies. They are a separate internal architecture, and I'll talk a little bit more about that as well. From a practical standpoint, doesn't matter, unless you're just trying to win some trivia contests with people at work. The big difference between a 4300 and a 4400 is the number of power supplies you can put into the router. Okay? Yeah? Does it have to be an RPS module? There is no such thing as an RPS module anymore. Yeah, we got rid of RPS modules. Yes, that was on a crusade to get rid of RPS modules because that was not fun. Now this is where we get into some areas where I have some reference slides. Anytime you see this for your reference up here, that's a note to me to just basically, just fast forward to the slides. Unless you guys have questions, I'm not going to dig into too much details. We've got a lot of individual platforms with different capabilities. I try to put them all here in the presentation, so you guys can download them. You can take a look at it. Basically, the 4451 is the first one the first box that we came out with. It's basically a 2RU platform. It's the most common high-end platform that we sell. 2 power supplies. Like I said, I call this the Darth Vader design because it looks like an Empire. You remember the Darth Vader when he was fighting? Anyway, looks like that. The 4431 is really just the top rack unit of the 4451. Literally, it is basically this router with just that top rack unit cut off. That's a 4431. And that's basically where you get that. It's only the network interface modules. There's no service modules available in that box, but it is still dual power supply. Moving down to that into the 4300 series, the 4351 is basically the same sheet metal as that 4451. It could have dual power supplies, but product management decided that they didn't want to do that. So it's just a single power supply there. It is a slightly different CPU architecture, so it is lower performance than the 4400 series. The 4331, probably the most common 4K that we actually sell. It's versatile. It fits into that 2811 kind of footprint for people. And the big thing that people didn't like about the 2901 is that it didn't have a NIM module or a network module in there. This brings that back. So this was designed specifically to address 2811 use cases. Maybe not the price, but certainly the form factor, the fit, and the number of interfaces there. Okay. So really, really versatile router. We see a lot of those kind of out there. Moving down a little bit, those were all 19-inch rack mount routers. We moved down to the 4321. This is our first kind of desktop form factor. You can see it's an external power supply here. It's designed to be quiet. It's designed to sit on a desk somewhere in a public environment. We do make a 19-inch rack mount kit for this, so we do see people rack mounting them. It's just that's really not how it was designed. It's designed to. If it only held the power supply, I know.
If the power supply was about an eighth of an inch narrow,
I do not disagree with anything that you're saying. Yes.
It's a converter these days, not technical these days.
Oddly enough.
They don't want to put the dual power supply in 4300 because if anybody wants a dual power supply, they have to go 4400.
well, I don't want a dual power supply. I just want to run it in it.
What he's talking about, just for you guys, so that we're not just having a conversation up here, is that the 4321 does have an external power brick, and we do have a 19-inch rack mount kit. The two don't play very nicely together, because if you have a 19-inch rack mount kit on this guy, you've got to figure out where to put this big power brick that sits beside of it, and there's no easy way to do that. Now, ironically, what we did with the 4221, which is just basically the small brother, the small cousin to that 4321, is we actually designed a 19-inch rack mount kit that actually holds the power supply brick with it, because it was such a pain in the butt for us that we did it for this guy. So I don't disagree with anything that you're saying.
So,
Yeah.
so does that work with the 4321?
No, it does not. Does not.
The power supply is an eighth of an inch too thick.
It is a little bit too thick. So anyway, the top of the line 4K today is the 4461. I put this in here at the end because this is actually the most recent one that we just launched last year. The main use case for the 4461 is high density voice, to be honest with you. In most cases, if you need to go faster than a 4451, you're looking at an ASR 1000. We see a lot of overlap in those use cases. But if you need lots of modules to fit in here, if you need UCSEs and a 48-port switch, you'd be looking at a 4461. It also has the biggest CPU, so you can forward 3 gigs and above of performance. So, that is definitely our biggest ISR 4000 box.
Did they fix QoS on the switch modules in the ISRs?
Did they fix QoS on the switch modules in the ISRs? It's a Catalyst switch module, so I know nothing about that. So, basically, what I will say, that's a good point that I'll bring up here. We do have integrated switching on all of our ISRs. There is a difference, though, in our SM, our larger service module switches, and our smaller NIM modules, or network interface modules, which we don't actually have one, but it would be right here. The smaller network interface modules, those are basic layer 2 switches. They're just going to give you your basic layer 2 functionality. It's not going to do much more than some VLAN, some basic QoS, some trunking, that kind of thing. The larger service modules, those are full-blown Catalyst switches. So those are 3560s in this particular example. So they're going to have all of the features of a Catalyst switch. So depending on what type of QoS you're looking for, there will be some there.
Will the NIM modules have QoS?
Will the NIM modules have?
Switch modules, because they don't on the 2900.
The NIM modules will have QoS. It's not going to be the same level of QoS as a SM module. You're correct. In the 2901s, they do not have any kind of QoS. Yeah. Good.
On the large switch module, does it run its own version of iOS?
The large switch module runs its own version of iOS. It is a completely, another case of me saying more than I should. We call it a power-sucking alien because it is essentially a power-sucking alien. Yeah. To be honest with you, though, if you actually look at the common sources of failure, the common contributors to uptime in a branch, if your switch is mission critical, and you have everybody plugging into your switch, so it is, and if your router is mission critical, you actually increase the overall uptime of the branch by reducing power supplies and fans by a lot. Those are the most common sources of failure in any box. So this is actually a more reliable solution than a separate router and a separate switch, regardless of who the vendor is. And I think we actually charge a little bit less for the module than you would for an external switch of the same size. So. End of sale dates for the ISR G2. I'm not going to cover these, in a whole lot of gory detail, other than to say you can't buy an ISR G2 anymore. So we've announced all of the end of support dates. We've announced all of the end of hardware and software supports. So, just kind of keep that in the back of your mind. If you're still running, ISR G2s out there in your network, it's time to start thinking about, what your plans are going to be. All of this is publicly available on Cisco.com, and so this shouldn't be a surprise. I'm just kind of putting this out here as kind of a kick in the pants, if nothing else. Migration path. This is not entirely straightforward. I did this slide a while back to give you some guidance anyway. If you're looking at physical migration, where do I need to go to get the same number of interfaces? This is a pretty good place to kind of start. If you're coming from the high end of the ISR G2s, you'd start looking at probably a 4451, unless you've got a lot of interfaces, a lot of modules. That would push you up to a 4461, and then so on and so forth, kind of down the portfolio. If you were around and you remember the ISR G1 to G2, God, we made it simple, because it was literally just a one-to-one mapping. We literally changed an 1811 or a 2811. The migration path for that was a 2911. So we just literally changed a digit, and it was easy. This is much more convoluted. Because we're changing architecture, so you're changing, a little bit in terms of speed and performance. What I can say, though, is if your bandwidth needs aren't dramatically increasing, a lot of cases we've seen customers move down and save some money. It doesn't always happen, but this is a good place to start that conversation.
Why do you not put the performance numbers on the right with the licenses, meaning Exatel, that they compare to?
Why do I not put the performance levels with the licenses? Because on this side of things, performance was non-deterministic. I couldn't tell you what performance level you're coming from on the ISR G2s. The benefit and the curse of the ISR 4Ks is that performance, to some degree, is deterministic. It's that ASIC-like performance I mentioned. So. pros and cons. All right.
But that model on the right won't work for the one on the left unless you buy a license.
In some cases, yeah. Starting point only. That's kind of where I can't do exhaustive for everything. Okay, how many people came here to see block diagrams? Come on, it's a Cisco Live breakout session. It's a product session. How many people came for block diagrams? Come on, there's got to be more people here that like block diagrams. I know when I go to a Cisco Live session, I expect to see block diagrams. And then, come on, fine. Here's my block diagram. So the 4400 series architecture, and this is where I'll draw out some of the differences between some of the portfolios. The 4400 series uses a physically separate control plane and data plane CPU. It's an Intel x86 control plane, and it's a Cavium multi-core data plane. That's not going to be on the test. That's just there if you need it. So it's physically separate. Now, what that really means practically is if you open up the lid of a 4400, a 4451, or a 4431, you see two different banks of memory. And that's really the only time you're really going to run into that as an actual situation. If you're doing a memory upgrade and you need to open the lid and say, hey, I need to upgrade my data plane memory, which you almost never need to do, or I need to upgrade my control plane memory, which you might do if you're running as a route reflector or something like that, you just need to be aware of the fact that there's two different banks of memory and you need to make sure you're upgrading the right one. So all of the packet processing happens here in the data plane. All of the control plane happens here in the control plane CPU. Kind of makes sense, right? Since that control plane CPU isn't doing anything other than really building the forwarding tables and programming that data plane, it's got a lot of spare time on his hand. It's really just sitting there idle. It's kind of bored. It doesn't have a whole lot to do. So that's where we do application hosting. We're running Linux there. We host KVM. We do LXC. We do Docker containers there. That's where they live in the 4400 architecture. Okay? Now, how we get packets in and out of the data plane, we have this thing called a multi-gigabit fabric. That's just a layer 2 switch. So that's how all of our modules, all of our front panel interfaces, that's what FPGE means, front panel GigE, those all connect directly into the data plane. So 100% of packet processing happens in that data plane. If a feature doesn't exist in the data plane, it doesn't happen. There is no punt path as we used to have on some older platforms. There's no fast path and slow path. It's all data plane. Okay. So the packet flow in the 4400 series, this is the price of admission, right? This is your block diagrams, right? So what do? How does that actually work? Well, first off, that control plane programs the data plane. It builds all of the forwarding tables. It tells the data plane how to do QoS, how to do application performance monitoring. It tells it how to do everything in the box. Once that happens, control plane's out of the picture. It really doesn't have anything to do. If a packet comes in from the front panel, gigabit Ethernet interfaces, if it goes out through a network interface module, it goes out through a service module, doesn't matter. Everything goes through that data plane CPU, regardless of where it's going, where it's coming from. If it's going to a service module, one of the big Ethernet switches that we were talking about, that's all kind of consistent. It does everything, in that direction.
Where's the NetFlow data come for the first string?
NetFlow actually comes from the data plane. The only exception to that is layer 2 traffic that stays within that multi-gigabit fabric, and that's an important distinction. Anything that goes through that multi-gigabit fabric doesn't count against your box performance. So layer 2 traffic never touches your data plane. If you have something like a UCSE module, you have a switch in there, and you have local users on your local Ethernet switch accessing your UCSE module, they can do it all on the same VLAN. There's no reason to go up to layer 3 and get forwarded just to stay within the branch. That all stays on that multi-gigabit fabric, never counts against your router. Yeah? Can you do NetFlow over the management interface? Yes, you can. It just basically sends it this direction in that case.
So
Yeah.
you get NetFlow visibility of traffic on that bottom fabric?
Do you get NetFlow visibility down here? No, you would not. That's layer 2. Yeah, exactly.
Well, NetFlow's layer 2 also.
NetFlow can be layer 2, but not on this.
That's the way you have it.
I mean,
6,000 rocks.
the way you would do that is if you had a layer 2 switch in there in the SM, you could get NetFlow from that. But you don't get this is a very, very basic Marvell layer 2 switch. So you don't get anything like that from there. Okay? All right, 4300 series architecture, and this is just to win that trivia contest and just so you get one more block diagram. The 4300 is all just a single CPU architecture. So it's just one large 8-core or 4-core, depending on platform, Intel x86 CPU. And what we do is we basically carve out cores. Most cases, it's 4 cores for the data plane, one core for control, and then we leave 3 cores kind of sitting there idle for applications. Okay, so that's kind of the big under the hood difference between a 44 and a 43. Like I said, the big difference is going to be power supplies. That's really all anyone really notices. ASIC-like performance, this is kind of what I was talking about with our performance curves of the 4400 to the 4300. A traditional router like an ISRG2 or an 800 series, as you add features, every feature that you add, you get slightly less throughput out of the box. With an ISR 4000, as you add features, you get kind of deterministic performance. You will always get that 1 gig or 2 gig on a 4451 level of performance. Now, eventually, you can load it up to the point that the performance curve will start to taper off, but even still, it's going to be a shallower slope than a single traditional CPU architecture. Okay, that's both a blessing and a curse of the 4400, like we were talking about earlier. If you have a very, very light set of configurations, a very light set of features, 4400 is going to be a little bit crippled because we're not using the full capacity of the box. If you have a really heavy set of features like iWAN or SD-WAN, which is where this box was designed, you're going to get pretty stable, pretty predictable performance. It's going to look a little bit like this. This is some of the performance, some of the test cases from a 2911 versus a 4331, and then 3945 versus a 4431. And you can see the blue lines are basically the ISR 4000s, and you get pretty stable, pretty predictable traffic as you do complex QoS, NAT, firewall, IPsec, IPsec and firewall, and then IPsec and complex QoS. So you get pretty predictable performance out of all of those. The biggest takeaway, though, is what's the data plane CPU doing on both of these? On the ISRG2s, the data plane's around 100% because you're at your NDR rate, basically.
Is this with no performance licensing?
This is with this would be, actually, it technically doesn't matter. This is and that's a 44, this is with performance license. Yes, this is with performance. Not with boost, not with boost. This is with performance license, but not with boost. So anyway, the takeaway here is that your data plane CPU is still pretty lightly loaded here in most cases. Now, eventually, you do start to taper off here, like you do on this 4431, and that's where you're approaching that heavily loaded data plane core. Okay. Now, that's where I'll introduce the boost license. So we have 2 performance levels where we add in additional CPU cores. We've got a third, which is the boost license that basically just removes all performance caps. Now, it's important just to know that this doesn't always increase your performance. The only time that it will increase your performance is if you're over here where you're actually running out of CPU horsepower. Actually, I'm sorry, take it the other way. The only time it will increase your performance is if you're over here and you're running up against that bandwidth limiter before you run out of horsepower. If you're actually running out of horsepower, you may or may not see performance based on which box that you're on. So that there's kind of a little bit of a caveat there. So moving from a performance license to a boost license does give you more of that traditional performance curve. You do get a drop off with every application, with every feature that you add, but you do get a pretty significant performance boost. A 4451 goes from 2 gigs to 4, roughly. A 4351, the real improvement in performance is on that 4300 series. Since that's a single CPU architecture, we can reallocate cores. So we move some of those services cores over to data plane cores, and you get a dramatic performance boost. A 4331 goes from 300 megs to 2 gigs on the same platform. And in these tests, we were actually running out of physical interfaces on the boxes. So keep that in mind. You do get a significant amount of performance, but you cannot host applications because there really is no place here to host applications anymore. We're repurposing those cores on a 4300 to actually be additional data plane cores. Okay, so just kind of keep that in the back of your mind. If you ever run into a situation where you think you might need a little bit more performance out of an ISR 4000. Boost license is relatively new. It's about a year old. It's not brand new, but it's reasonably new. Yeah. Yeah. There are some gotchas. I put these on a slide here so that you've got them if you ever want to look into this, individually. You do only add performance, if you were limiting performance due to the performance license. If you were at a point where you were dropping off below that license level, a boost license may not do anything for you, but your mileage may vary. That's the case where if you think you might be in the case of a boost license, talk to your account team, send me an email or something like that, and we'll dig into the answer and what you're actually looking at. Okay, any questions on the ISR 4000? All right, good questions. So moving on to the ISR 1000, this will probably go a little bit faster because you've got the basic architectures. You've seen the block diagrams, right? Anybody want to see more block diagrams? I can pull them out, I mean, if you want them. ISR 1000 should be pretty straightforward. This is the new Cisco design language, by the way. There's a company, an Italian company called Pininfarina that designs Lamborghinis, and they do all kinds of industrial design, and they did this design language. Just the fact that they call it a design language makes you know that they're real good. So anyway, that's what general Cisco boxes are going to look like. The ENCS, a lot of the Catalyst boxes, a lot of our platforms are looking like this now, this nice kind of look. This is an iOS XE router. It's the same architecture as the ISR 4000. It's just a smaller footprint. It's a different CPU architecture in that it's not an x86 anymore. It's now an ARM-based CPU. It's a big stinking deal for us. Not necessarily a huge deal for you guys. It just means that we were able to build an affordable, smaller router that kind of fits that gap between 1900 series and 890, that type of range. Does have full support for SD-WAN because it is an iOS XE router, so you do get that capability. A lot of different platforms in the series. We have really two different CPU architectures, two different performance profiles in the ISR 1Ks, and we differentiate those by the number of Ethernet switch ports that we have. It's an odd thing, but hear me out here. The more switch ports you have, the more performance you get out of your device. We have two different variants. We have a 4-port and we have an 8-port version. So the Dash 4P, that's going to be a 4-port version. The 8P, that's going to be an 8-port version. This guy right here is a little bit of an oddity. He's actually the 4P CPU in there. But you'll see two different performance profiles between those two. Now, we've completely left behind all of that performance-based licensing that we had with the ISR 4000. I'm not going to say that it was a bad idea, but it was something that we learned from that situation. So now everything is just basically limited only on crypto throughput. That's the only place where we enforce performance levels on the ISR 1Ks. And that's something we have to do. U.S. Department of Commerce says that we can't export. There's lots of laws that we have to follow with crypto performance. So that's why we limit based on crypto performance here. A lot of different variants, a lot of different versions here. There's the 11.1 that basically hits a 250 or 350, whether you're a 4-port or 8-port. There's the 11.01, which is a smaller, compact form factor. And then we've got a larger version here in the 11.11, the 11.09s, which are extended temperature range, not quite an IoT box. A lot of different variants, a lot of different form factors here. We've got some new guys that are coming out later this year, the 1120 and the 1160. They're just basically the existing 8-core performance, and the 1160 is just a faster, great, big, huge, honking ARM CPU. So that's going to be our highest performance in the ISR 1K family. Up to 500 megabits per second. If you remember what we had back there on that ISR 4K slide, you're looking at a small kind of compact box here that can just smoke the doors off of like a 4331. That's just the nature of more modern CPU architecture, something that was designed in 2018, 2019 versus something that was designed in 2013. So that's kind of the reality there. Okay.
How
Yeah.
limited is the encryption?
How limited is the encryption?
Yeah,
It's
flavor for here, because like we got big GMV.
It's the throughput.
it's the throughput. It's just the throughput.
Well, I know, but
Yeah.
is it half this? Is it full of what you're stating?
So basically it's limited to. I can never remember.
Tenth that, it just-
No. The default crypto throughput, I think, is limited to something like 35 megs. I mean, that's the unlimited, U.S. Department of Commerce crypto limit. 35 megs in each direction, 2,000, I think it's 2,000 tunnels. I'm going to get it wrong if I try to quote it. But there's different export categories, so that's where the limitation is. If you're doing crypto on these boxes, I would always recommend that you buy the HSEC license for these, which is it's not huge, but it just uncaps it. It uncaps it. Unless you're deploying routers in Iran or North Korea. Are you deploying routers in North Korea? If you are, okay. Those are the only. And I think Cuba was off the list, but they're back on the list, so go figure. And this is kind of a quick little cheat sheet for you just in terms of ISR 1K performance levels. This is basically just a crib sheet for the CPUs we put into them. You basically got the 4P, which goes up to 250 megs of crypto, and then you've got 350 megs of crypto on the 8P, and then 500 megs of crypto on the 1160s. Okay. If you're not doing crypto, they can do more than that. Can't tell you what they'll do because that's complex. Form factors, these are all pretty small. I mean, this is a 12-inch. The biggest one that we have is a 12-inch wide device, about 4221 kind of size, more or less. Moving down from that, you've got the 1101s, and then the little tiny guy, the 1101 4P, is tiny. It's about the size of a paperback book. How many of you guys are old enough to remember what a paperback book is? Okay, well, that's about an 1101 4P. So it's a nice kind of small, tight form factor. All of these are passively cooled. There is no fan in any of these. Okay? The 1109 is not an IoT device. We call it an extended temperature range router. It's designed for kiosk. It's designed for point of sale terminals in some places. It's a little bit hardened, but it's not really fully hardened. It isn't going to go quite all of the way. It's going to go down to 15 degrees Celsius and up to 55. It's not going to have any significant dust or moisture protection, but it's still going to be fairly flexible. Okay. Now we do have, not technically part of our group, but we do have an offshoot of the 1100, the IR 1101. Now this is a fully IoT industrial router. That's where the IR comes from. Now the IR 1101 is just getting launched right here. It's actually with the World of Solutions. You can actually go over to the World of Solutions and see a great big, like 3-foot version of this, which is kind of the opposite of a small router, but it's pretty cool. I was impressed by it. This is all based on the 1100 design, but the IoT team basically takes that design and hardens it even more. So it's designed to be DIN rail mounted. It's designed to go into those types of rugged environments. It does use the same pluggable module, but it does go from minus 40 to plus 60 degrees Celsius. So pretty heavy temperature range. Yeah?
We could really use them like that with a T1.
You could really use some of those with a T1. T1 is on our roadmap for building into this smaller pluggable form factor. Not there today. I don't really even.
Like to deploy them, but we have to.
Okay. Shoot me an email. Shoot me an email. I mean, it's not, I don't have the exact dates. It's not anytime imminent. I think the next ones we'll be having are G.SHDSL maybe, and ADSL. But yeah, T1 is somewhere.
It's committed on the roadmap?
I wouldn't say that it's committed. I'm a TME. Nothing's committed for me. Neat thing about this router, which I think is really neat, is it has an expansion chassis up here, which is basically just tacks onto the top. What makes this really cool is that, especially in industrial environments, you already have a 4G LTE modem here. That 4G LTE is dual SIM, so there's only one active radio, but you can have a primary and a standby service provider. Pretty cool. If one goes down or one degrades, you can switch over to the secondary service provider. That's cool. With the expansion chassis, you can add a separate module there. It could be DSL or T1, or it could also be 4G. So you could have 2 active LTE providers with 2 backup, with 2 stand-ups. So you could have 4 simultaneous providers, 2 active and 2 standby in this scenario. So that means that you could be completely wireless and still do dual WAN links for doing SD-WAN and that type of thing. So pretty cool. It's the same code as the 1100s, yeah. It's literally the same architecture. Yeah. It's a Sierra, yes, on that one. On that one, I believe it is Sierra Wireless. Don't quote me on that. I believe it is.
Is
Yeah.
that managed as 2 separate routers then?
No, this is just one router. This just adds additional interfaces.
Okay.
Yeah. Hey, go over to the World of Solutions. You can see it over there. It just literally pops down onto the top. Yeah. Okay.
That is big.
I know, it's massive. I want that for home. Yeah. I wish it was really functional. This is the newer module type that's in that ISR 1100, IR 1101. We built another module type just simply because we needed a smaller form factor for those guys, and it's slightly less expensive. This is USB on the back end, just to connect internally. Our NIMs and our SMXs are all Ethernet based. This just gives us a little more flexibility with direct modems and controllers that already have USB interfaces. That's the main reason we did that. Okay. Mobility Express, that's another thing that I'll point out that's available in any of the 1100s that have a wireless LAN AP. The AP in an 1100 is basically an 1805 access point. So it can be autonomous, it can be CAPWAP, and it can also do Mobility Express. So it can actually act as your wireless LAN controller for an entire branch of Cisco access points. So you can do a heck of a lot of stuff in that small little 1100 series. Okay, so that's just kind of pointing that out there, that Mobility Express is an option for us here. Okay, any questions on the 1000s ISR 1Ks? All right, how many of you guys have been waiting for the 900 series? I've been building it up all this time. Are you guys excited for the 900 series? I am. I mean, I love this box. So this is the kind of the existing portfolio that we've had. We've got the 800 series that we've had forever, and we're constantly adding and tweaking and changing things there. But generally, we have three major categories: the 860s, the 880s, and the 890s. As you go up in price, you go up in performance, basically. The 1100s kind of address the high end of that portfolio, that especially the 890 use cases, but it was really still too expensive to address that 860, 880, and some of the low-end 890 use cases. That's where the 900 series comes into. So I've been talking about how great iOS XE is and how wonderful iOS XE is for the ISR 4000, for the ASR 1000, for the ISR 1000. ISR 900 is another classic iOS-based box. It's probably, I'm not going to say it's definitely, but it's probably close to the last classic iOS router that we'll build. But it's just the CPUs that are out there that are available today allow us to build a really fast single CPU classic iOS-based device. And that's the 900 series. There's so much capability in classic iOS. There's so much already there that it just made sense to come out with this device to cover that low end of the portfolio. So if you have existing 800 series, the 900 is basically a drop-in replacement for those. Same configurations, same basic architectures. High performance, easy to deploy. Literally, it's just it's the same code base as those 800 series routers. Same general capabilities in terms of connectivity, ADSL, DSL, LTE options. You are going to be limited. We're only going to do Cat4 LTEs. We're not going to do Cat6 and above LTEs, but that's okay because you're looking at lower throughput kind of levels here. Okay. So the upgrade path, what would you be looking at? Well, if you're on an 890, we would generally point you to an 1100. If you're on an 819, you'd still probably want to go that direction to an ISR 1K. If you're on the 880, the 860, those areas, you're probably looking at more of a 900 series. Now, the other thing to keep in mind is if you're looking at going down the SD-WAN path, these are not iOS XE routers, so you'll never have an SD-WAN option on an ISR 900 series. So just kind of keep that in the back of your mind. Not going to be an option. They are supported in DNA Center, though, so you do have the ability to manage these guys with DNA Center. You're just not going to get all of the new great stuff that you get with SD-WAN. Okay. A couple of these slides in here that I'll just leave here for you guys to kind of look at with some comparisons of the 1000 versus the 900. I'm not going to go into too much detail. Really two major form factors, and the real big difference between those two form factors is an internal versus an external power supply. The internal power supply just gets me excited. I just love that. No power brick. It's a nice, small, slightly larger than a paperback book kind of version, but just a really nice, small, compact kind of router. So there is an external power supply version of that as well. You do get more capabilities on the 926, 927 with that power supply removed, but for folks that are just looking for something compact, 2 1 gig uplinks, a 4 gig switch, you can't beat that in a lot of cases. Okay? And a couple more slides that just comparison tables I'll just leave you guys with. Okay? Any questions on the 900 series? 1Ks, yeah.
How does the IPsec performance compare to the
How does the IPsec performance compare with the
2P?
It's not really comparable with an 1100. It's going to be below an 1100 in almost all cases, IPsec included. Yeah, I wouldn't even say almost all. In all cases, it's going to be lower than an 1100. A little bit difficult to say, simply because it's drastically different architectures. This is an Intel CPU versus an ARM CPU. This is a classic iOS versus iOS XE. So it's really hard to compare the two. You might get really good performance in one area, but not in others with this.
So in terms of the software features, so the ISR
So in terms of software features, that's a really good question. So you will never get all of the same software features on a 900 series that you do on a 1100 or on a 4000, simply because different code bases, completely different architectures. If we followed our executive directions to the T, we would never have built the 900 series because the direction is everything moving to iOS XE. There's just too many options out there for us to build a small, compact, classic iOS router today. So you will always have if you're looking at the feature comparison with an 800 series, it's going to be identical with a 900 series.
But 1100 has all the features 4000.
So the 1100 has all of the features of the 4000 minus some things like voice. Yeah, yeah, yeah.
All the data stuff, like the box redundant.
All the data stuff should be there. I'm trying to think of a caveat to that, but yeah. Yeah, it's definitely the same code base, and I don't think we fenced that anywhere.
What channels with the 1100?
Port channels are not supported today, but they are on the roadmap. Yeah, that's an architectural thing, though. That has something to do with more of the hardware underneath the ARM CPU than anything else.
They haven't capped any of the routing, like stub routing.
We did not cap anything on the 1100, except for IPsec. That's the only thing that was capped on a 1K. 900 is not capped at all, and their crypto performance is below the export limits. So I don't think there's even an HSEC license on the 900. Okay? All right, NFV. How many people are excited about NFV still? All right, a couple of people. So how many people are new to NFV, have never been exposed to it? So I'm going to go through this kind of quickly just to give you an introduction to it, what we've got going on. So NFV the whole concept of NFV in the industry has really followed what happened in data centers. Years ago in data centers, we had application servers for every possible use case, every possible application. Virtualization happened, and you never have dedicated servers anymore. Everything is virtualized now in the data center. And NFV is kind of following the same kind of trend in the network in general, especially in the branch environment. So in the physical branch, you typically have a router, you'll have a switch, you'll have a wireless LAN controller, you might have a firewall, you might have an application server, and those are all physically separate devices with separate CPUs that are largely just sitting there idle most of the time. NFV basically says, well, instead of that, why don't we have just one great big repository of resources, generally x86 and memory and storage, and let's run all of your functions there as a virtual container inside of that. And we can flex the resources available based on what the needs of the network are at the time. Now, you're still going to need some physical interfaces to the rest of the world. If you have a DSL interface, you're going to have to do something there. If you have an LTE, you're going to need to do something there. If you have an Ethernet switch, that's typically something specialized. There's a lot of really big benefits to both enterprises and service providers. The real key benefits that I think really resonates a lot of times is for enterprise customers, you don't have to do a truck roll. You can roll out a new service, you can roll out a new application, a new network function without ever physically, visiting the site, without ever physically visiting the location. From a service provider, sort of that same benefit means that their enterprise customer can now order a new service. Maybe it's an anti-spam, an antivirus type of service, and some kind of an IPS filtering service. They can just simply roll it out and provision that, in a matter of minutes rather than days, weeks, months to send hardware, out there on site. So that essentially is the gist of the big benefits to both cases. A lot of folks approach it from saying, I'm going to save some money here. I'm going to have more appropriate sizing of my x86 and CPU and memory and everything. The reality is you're still paying a licensing fee for every single one of those VNFs, so you're probably not going to save a whole lot of money up front. So that's just to dispel one of the things that a lot of people go into NFV kind of looking at that as, hey, I'm going to save a ton of money. Probably not. The actual hardware is not the most expensive thing in most cases. Generally, it's the software. So Cisco's Enterprise NFV, we basically designed this from the ground up. So we designed every single component of our NFV solution, all the way from hardware up through software, operating systems, VNFs, virtualized network functions, all the way up so that it all kind of fits together. And this is sort of the stack view of that. So we've got physical hardware, whether it's an ISR 4000, the ENCS, the Enterprise Network Compute System, or an actual UCS server. We support all those different pieces of hardware. On top of that, we run an operating system called the Network Function Virtualization Infrastructure Software. That will be on the test, by the way, so that is something you need to remember, please. I honestly I can't apologize for that name enough. NFVIS is the name there. And there are some bells and whistles that are added into there that it's a little bit more than just basic Linux. And then on top of that, we have network functions, both from Cisco and from third parties. It's completely open. You can run really anything that you want to there. On top of that, we've got APIs, we've got management tools, we've got things like DNA Center and NSO that let you actually manage and configure and deploy these guys. Okay, so what does it look like at all of these different areas here? Well, the ENCS is probably the most unique box that we have. It actually looks, we've got a couple of different flavors here. We've got the 5400 series and the 5100 series. You could be forgiven for assuming that this is an incestuous relationship between a UCS C-Series server and an ISR. I would completely forgive you for assuming that, because that's exactly what this is. We basically designed it in the ISR team, but we took a lot of the hardware. We actually took the drive carriers from a UCS C-Series, but we enhanced them. We made them better. We made them stronger. We actually added shock and vibration protection to the drive carriers so that they fit a little bit better into a branch environment. We still have the network interface modules from an ISR, so you can now have 4G, you can have DSL, you can have T1E1 on this box, which you would never get into a traditional server. We have an 8-port Ethernet switch, which you're not going to get in most servers. It's also less than 12 inches deep. It's designed to fit into a branch environment. It has a VGA. This one has a VGA connector. The 5100 does not. It is a server, essentially. For everything else that it is essentially a server as its architecture. Yes. We also have the 5100 series, which is just basically the small brother to that. It's a lower core count, smaller device. It actually has a built-in 4G LTE modem, so all of the same general capabilities. Now, how do you do VNF sizing? How do you do virtual machine sizing? Well, you take a look at all of the CPU cores that you need with all of the different virtual network functions that you have. So we basically say, okay, this is a 5412. This is the biggest ENCS that we have. It's a 12-core Broadwell CPU. We're going to reserve one of those cores for the host operating system, for the hypervisor, for NFVIS. Beyond that, we're going to run a virtual router, ISRV, basically a virtual ISR. It's a slightly tweaked version of the CSR here. That's going to take between 1 and 2 cores, depending on what you need to do with the box. And then you're left with 10 additional CPU cores that you can allocate with whatever you need. You may need to do a firewall. You may need to do WAN optimization. You may need third-party Linux, Windows, virtual machines, totally up to you. So we don't place any kind of restrictions or really even give you too much guidance on how many VNFs you have because it's a virtual environment. It's just like a server. You have this amount of resources, and this is what you need on top of it. So there's a little more thought that has to go into an NFV world than in your traditional physical hardware world. Okay? Now, that NFVIS operating system I talked about, that's a little bit more than just straight Linux. We actually start with CentOS. It's actually a CentOS distribution, but we add a lot of stuff on top of it. We add things like service chaining. We add things like APIs. We add things like Cisco zero-touch provisioning for like plug-and-play management. So you can send this out to a remote site with no configuration on it whatsoever. It will download its full personality, all of its VNFs, everything that it needs. So pretty cool capabilities that are built into that host operating system. That host operating system, by the way, can also run on a UCS C series. If you need that to run in there, it can run on a UCS E series inside of your ISR as well. So you've got some options there as well. Okay? The actual VNFs available from Cisco is basically everything that you would expect. So everything that we have a virtual network function for that might be provided in a data center, you can support it, you can run it on a ENCS. That's typically going to be your virtual router, ISRV. That's going to be things like your virtual firewall, your virtual ASA, your virtual WAS, virtual wireless LAN controller, and then really the sky's the limit when it comes to third-party VNFs. This is a Linux environment, so we're really talking about KVM here. So if that matters to you, you're not going to be running things like VMware virtual machines here. That's a 4-letter word in a lot of these in the Cisco environment anyway. So just keep that in mind. Management and orchestration, that's all done through DNA Center today. well, today and tomorrow for the future. So you do all of your rollout, all of your management, all of your virtual cabling, all of your virtual racking and stacking that you would have typically done in the physical world, you now do it all through software. And that software is a component of DNA Center. So you're allowed to just basically come in here and start with a completely blank palette. This is all just a single ENCS, for example, or a single branch design where we have 2 ENCSs and we're connected to 2 different service providers. We're going to be, defining what the VNFs are that go inside of it. We can define all of the different VLANs and the different virtual networks and how they're physically stitched together, virtually stitched together, I should say. So just think of it as you would traditionally, cable things with an Ethernet cable. You're now just drawing lines on a screen and rolling those VNFs out. Okay. Quick little overview there for NFE. Okay. Yeah.
So I have 2 questions. You have a star on FTD on the ASA on that flat back.
Yeah. Was that?
On my presentation, looks like
Shoot me an email on that, and that's firewall threat defense. And yeah, shoot me an email on that. That was probably when I did that slide. I don't think it was supported. It should be today.
Okay.
Yeah.
So my second question is regarding DNA Center, that's a requirement for that box.
DNA Center is a requirement to orchestrate this box, unless you want to do it. I mean, this box does have an on-box GUI. If you just want to do a single box at a time, you can do all of this without DNA Center. Yes, but that is only going to be, if you want to do more than one of these boxes at a time, you do have to use DNA Center. Yes. Yeah. Okay. SD-WAN. Okay, so how did we actually take that Viptela integration and get it into those boxes, those ISR 4000s, those ISR 1000s? So if you look at what our SD-WAN portfolio is, it's essentially all of our iOS XC routers. So that would be the ISR 4000, it would even be the ASR 1000, it would be the ISR 1000, it would even be the IR 1101, so the little guy there. Anything that runs iOS XE from a router standpoint can run SD-WAN. And the reason I say that is this is actually how we did that integration with Viptela. So we actually took the best of both worlds, and it made the integration actually go pretty seamlessly. And I can tell you more or less what your performance is going to be in the SD-WAN world. I can tell you that it's pretty stable. It's remarkably stable because we didn't start from scratch. We're not running Viptela code on an ISR, completely. So what we did was we took a traditional ISR. This is traditionally what the software would look like. You've got your schedule, your interfaces, your actual feature invocation array. That's essentially your data plane in an ISR or an ASR or any iOS XE device. That's going to be your data plane. And we have our traditional control plane. That's classic iOS. That's actually managing, that's actually programming your data plane. And you typically would use CLI or SNMP or netconf-yang to interface into that. What we did in the SD-WAN world, that exact same stack, that exact same box, same physical hardware, same physical data plane, we basically just interfaced with what we call internally C-edge code. Don't repeat that. That's another thing that we don't have a good name externally for it, but it's essentially the C-edge code. Instead of V-edge, it's the Cisco C-edge code. And we interfaced with our data plane using just common netconf-yang models. So essentially, everything from here on down is exactly the same on both of these sides. So QoS works exactly the same in an ISR 4000, whether you're doing it in traditional iOS XE mode or you're in SD-WAN mode. Doesn't matter. The router itself doesn't even know. It just knows that it's getting a netconf call to configure QoS on this interface. The reason that works so well is that we took advantage of all the greatness that we had in our data plane, all of our features, all of our capabilities here. We didn't rewrite it from scratch, but we basically added this shim layer here to interface into the whole SDN world for the Viptela cloud. So that's really sort of the beauty of the way that they've actually done this integration. We didn't start from scratch. You don't have a dramatically different box. You've still got all of the things that you know and love about an ISR. You just have a different overlay, a different management model as part of it. So, it's not really going back and starting from scratch.
Multicasting?
What's that?
Multicasting in the SD-WAN.
Multicast is available in both sides, yeah. Yeah.
Features in multicasting?
Other features in multi?
All the features.
So one thing I will say is that we will never have all of the features from this left side on this right side. We don't want to, because it wouldn't really map, the whole concept of SD-WAN is that it's clean, it's manageable, it's easy to consume. So even though the data plane on this side understands 100% of the features on this side, there's no physical way for you, or there's no real way for you to configure it. There's no way to turn it on. So even though we may have, MPLS traffic engineering, take that as an example. That's something we support all day here. This data plane understands it, but you can't configure it. You can't turn it on through the Viptela standpoint.
Well, how do we know what are not there?
That would be the SD-WAN roadmap, which I have in a couple of slides. Yeah. So in most cases, that's going to be just doing this actual integration here to turn on that functionality, unless it's a completely new feature. Yeah. Okay. So bandwidth metering, I'm going to leave this here for you guys. This is a little bit of a head scratcher if I just explained everything from how we measure bandwidth on the traditional ISRs with bandwidth licensing and everything. In the SD-WAN world, bandwidth is measured a little bit differently. I'm not going to go into a whole lot of detail here other than to say that in the SD-WAN world, we're only talking about WAN bandwidth, and we're counting it in half duplex mechanisms. So I'm not going to go into a whole lot of detail here. Just be aware that it's a different way of thinking about things. We don't have the same performance licensing. We don't have any of that. None of that goes on in the SD-WAN world. It's completely different. Okay. SD-WAN security, we do have a lot of security capabilities, either in SD-WAN or non-SD-WAN. In the SD-WAN world, we've had to kind of simplify things a little bit, and most of this comes down to how much memory, how much DRAM you have available on your system. Now, on the high end of the portfolio, the ISR 4000s, the high-end 1Ks, or the ASR 1000s, they basically have everything available there because they have tons of memory, tons of resources. It's when you get down to the lower end, especially the ISR 1100s, that things start to get a little bit more tricky, and that comes down to how much DRAM you have, whether you have 8 gigs of DRAM or 16 gigs of DRAM. Yeah.
So on one side, I would like to have these on the 1K, join the viewer IPS, that's.
So the reason that the ASR 1K doesn't get a lot of this stuff is application hosting. That's where we're getting to with application hosting. A lot of that capability isn't there on the ASR 1000 because if we did application hosting for a lot of this capability on the ASR 1000, it would take a 40 gig box and drop it down to 500 megs. Probably not practical in most cases. So that's why you don't see a lot of this capability on the ASR 1000. If you're looking at that level of throughput, you're probably looking at a separate external box to do some of that. Yeah. Okay. So in terms of services, really we have 8 gig options, we have 16 gig options. We will run SD-WAN on a box with just 4 gigs. Of capabilities. But if you actually want to host some additional containerized services, you need to have at least 8 gigs of DRAM. So you can host basically one service with 8 gigs, or you can host 2 services with 16 gigs. That's sort of the easy way to really explain that. I'm not going to go into a whole lot of detail here other than to say, if you're looking at URL filtering, you can do that in either situation, but you can't do that with IPS and IDS. 2 different services, 2 different virtual machines that are running inside of the box that need to have access to resources. You need at least 8 gigs to run those. 16 gigs will let you run both. That's kind of it in a nutshell. Another quick slide for you to just give you a look at what is possible out here, and that's all tied to where we have options for 8 gig and 16 gig platforms, basically. SD-WAN performance, I'm not officially allowed to go into a whole lot of detail here. I actually tried. SD-WAN performance, I will leave you with just this one kind of thing to say. There's a big, vast range. I mean, ISR 1100 to 4461 is somewhere between 240 megs and 5 gigabits per second. That's what I'm officially allowed to tell you. I can tell you that SD-WAN, if you're doing deep packet inspection, which you are, for a lot of the overlay topologies. If you're doing enhanced security, that takes a big toll on the router. So you're not going to get the same level of performance you would with just pure IP forwarding. You would get a lot of the same performance you would have in an IWAN situation previously, because the data plane's doing a whole lot of work with some of these services. So take this with a grain of salt. We have a pretty broad range of SD-WAN performance capabilities. The last two slides for SD-WAN, I'm just going to leave it with you guys. These are all of the roadmap slides. These are all of the features that I was talking about earlier. A lot of these capabilities are already there in iOS XE. We're just turning them on with vEdge, with the Viptela SD-WAN overlay models. So this goes all the way up to next month's release. So there is another release coming in November. I can't officially show you that, but it's just going to add additional, more support on top of what we already have today, and additional platforms. Okay, these are the actual platforms that we have today. Okay. Any questions on SD-WAN? Just wanted to kind of give you guys a quick kind of overview of it. Okay. Last couple of sections here is all about application hosting, how we can host applications on our routers. A couple of different ways we can do that, today. With our iOS XE-based boxes, you can either host an application locally on the box itself, or you can host it with a dedicated server module, with a UCSE. So if you're looking at all of the different ways you can host an application in a Linux world, all the way from a native process built directly into the core operating system, all the way up to a Type 1 hypervisor like a VMware that runs, basically on top of a bare metal. You've got different options here. You've got a Linux container, LXC. You've got a Docker container, which is kind of a specialized version of an LXC container. And then you've got KVM, which is a true, real virtual machine. You've got your whole kernel. You've got all of your resources for that application there. Just some terminology. Linux containers is basically an LXC or a Docker container. That's how we would generally refer to those in the industry. Cisco Service Containers, or IOX, was a previous name. Service Containers was what we called our architecture before we partnered with the IoT folks and actually hosted IOX capabilities on our box. With that, you can host either LXC, Docker, or KVM directly on our devices. With our open service containers and IOX, we really just focus mostly on Docker and KVM. The reason for that is if you're doing an LXC container, that means that you as the application provider have to adapt to our kernel that we use internally, and trust me, you don't want to do that. It's a really kind of customized Monte Vista kernel that you as an application developer, you don't want to do this LXC, basically. It's kind of what I'm saying there. Okay, so you've got all these capabilities to basically host an application. How would you go about actually doing that? That's where IOX comes into play. If you've been over to the DevNet area, you've seen a lot of people talking about IOX. It's something we actually started in the IoT world, but it's since migrated to routers, to switches. It's a common way of developing and hosting applications on Cisco devices. We've got a ton of IOX-enabled devices, including ISR 1Ks, ISR 4Ks, technically the ASRs, although you probably don't want to run a lot of applications there. We've got developer tools. Really, DevNet is going to be the major conduit for you to interface with this. Basically giving you the capability to manage everything, to write everything. We're currently working on kind of a marketplace with partners where you can just go off and buy an application or download an application to run on your router. So you don't necessarily have to write all of these applications yourself. Okay. Now, a couple of these examples, things that we use this architecture behind the scenes. Cisco WAS, we can host that locally on an ISR 4000. That's basically running in a KVM application on the router itself. We're using the same tools, the same capabilities that you would as a developer to host WAS on the box. IPS, IDS, and even URL filtering, don't really have a slide on that. That's doing exactly the same thing. We're hosting the Snort application directly on the router in KVM. So we're hosting it there locally, just as you would if you were a third party. Now, there is a special option in IOX, and it's called Guest Shell. This is on any iOS XE device. You can just basically go in and enable Guest Shell. It will give you a completely sandboxed Linux environment. It'll give you a Linux prompt where you can run your own scripts, you can run your own code directly within a KVM Linux environment. You can knock yourself out. It's great for prototyping. It's great for running scripts, for doing whatever you want to. It's all embedded inside that iOS XE image. So it's something, if you're not aware of it, go check it out. It does give you some really cool capabilities there. Okay. Resource utilization, resource options here. I'm just leaving this up here for your reference as well, just to give you kind of a feel for what the service cores are, how many cores you have, what the CPU speed is, relative compute power, how much memory and storage options that you have. across the ISR 4000 portfolio. So just in case you get into that situation where you want to host an application, that's kind of a useful table for you there. The main thing is, if you're interested in something like this, go to developer.cisco.com, look for IOX. There's tons of stuff out there, code to get you started, resource guides, developer guides, those kinds of things. Okay, so that's if you want to host an application directly on the router or the switch or the IoT device. You could do it, all there. But what if you want a completely separate server environment? Maybe you want to run VMware. Nobody's perfect. Maybe you want to run VMware on your UCSE, or maybe you really like Cisco ENFV and you want to run NFVIS there locally in your ISR 4000. That's where the UCS E series comes from. So you're familiar with the UCS C series, you're familiar with the B series in the data center. The UCS E series is essentially just a smaller embedded footprint server that fits inside of your ISR 4000 or ISR G2s. We had them back in that generation as well. So they come in two different flavors, a single wide SM and a double wide SM, and just as you would expect, the double wide has more real estate, more CPU, more horsepower, so you can do a lot more in that footprint. So the single wide, you get 2 drive bays. You can do RAID 0 or 1 there. You've got a front panel KVM connector. You've got 2 memory banks there. You can go up to 32 gigs of DRAM. And most of the network access to the device is going to be to the mid-plane of the router. We do have front panel Ethernet here. For the most part, you're just going to be talking to the router itself on the mid-plane. If you have the real estate, maybe you bought one of those 4461s, so you've got 2 double-wide slots here. You can put a much larger 8 and 12 core Broadwell CPU on there. You can go up to 128 gigs of DRAM. We've got up to 3 drive bays on these guys, depending on what you're doing there. 4 on the newer the new M3 versions of these cards. You've got full KVM functionality. You've got front panel interfaces. You've got backplane interfaces. It's basically a server. There's not a whole lot to say about that other than the fact that you've got a bare metal server here. You can do really whatever you want to on that box. Okay. The one thing that I always like to point out, though, that we do unique on the ISRs that no one else in the industry, certainly no one in Cisco does, is that if you're buying hardware support, if you're buying SmartNet on an ISR, that ISR SmartNet contract covers everything inside of the sheet metal of the device. So if you have a UCSE server inside of your ISR and you have a hard drive failure, that's covered by the router SmartNet. So keep that in mind when you're pricing out things. Even if you had a UCS-C series and it was sitting next to the router, that would take its own SmartNet contract. You can save a lot by bundling things into that ISR. We want you to do integrated services on the ISR. That's why we just charge you one price for the router itself. So keep that in the back of your mind. Anytime you're adding an Ethernet switch to the network or you're adding a server or something like that, this can save you a heck of a lot of money. Okay? Any questions on modules? Anything that you guys are specifically interested in that you might want to hear about, or anything that you're curious about? This is kind of the last question and answer kind of moment. If you have dual routers, can you vMotion? Not within KVM. You can within VMware. Yes. But that's we're not really doing anything then. Yeah. Okay. Any final thoughts? Any final questions from you guys? I can go into specific modules. We've got about 10, 15 minutes or so. About 10 minutes or so. Anything that you guys are curious about? Anything you want to hear a story about that you're just curious about why we did something, or why something was done a particular way?
On the Catalyst 3K that can be embedded,
Mm-hmm.
is there any plan to bring that up to like a 9K variant?
Is there any plan to improve the 3K switch module to a 9K? Yes. That's another situation where I can't talk anything more about that. Yeah. But yes. Okay. All right. So thank you, guys. I will leave you with one last thing before you step out of here. Please do your evaluation, and that is absolutely, completely, 100% serious. I do this session 2 or 3 times a year in different cities and different Cisco Lives around the world. I read every single comment, especially if it's a 5-star review. I really appreciate those. But seriously, any comments like, hey, Matt, you're an idiot, or Matt, your fly was open the whole time. I appreciate those. It would have been nice if you told me 2 hours ago, but Seriously, any comment, any feedback? Like I said, bolick@cisco.com. If you guys want to ever send me anything there, I'm more than happy to track down answers or tell you something I'm not supposed to. I might have to call you since I can't have anything recorded. But seriously, you can always do that. By all means, please do the session evaluation. I'm just going to leave you guys with that. And I'll be up here for another 10, 15 minutes. Thanks.